Hello, everyone. Welcome on the next webinar by whyr Foundation. My name is Martin Koscinski, and I'm the member of the foundation. We have a pleasure to host Lorenzo Braschi today from Roche IT. Lorenzo is managing multiple projects at the same time, so we are really grateful that he has found a little bit of time to use his time during the evening tonight. We will have a pleasure to hear about development pipelines that are prepared at Roche, which is a worldwide known company. And they are well known for having multiple R projects developed in-house. A few sentences about Lorenzo. He, for now, has been working for 3 years at Roche as an IT and data science expert. Previously, he worked as an assistant professor at Universidad El Sabio for 4 years, where he was a professor of statistics. He's very talented and self-motivated data analyst geek who enjoys dabbling with information. He tends to say about himself that he's a quick learner who can absorb new ideas and new technologies in a speed of lightning. So happy to hear about the rZYPAD, I don't know if that's the proper pronunciation, and the development workflow at Roche. So Lorenzo, the floor is yours. Please, people post questions on a live chat so that we can have a Q&A session at the end. And good luck and have time. The floor is yours, Lorenzo.
Thank you for the kind introduction, and welcome everybody to this webinar. Share my screen. All righty, can everybody can you see my screen?
Yep, it's good.
Yep, that's cool. Give me a second until it loads. Ah, there we go. So rZYPAD, a rZYPAD pipeline for our projects. I'm going to talk a little bit about something we have a work in progress, about working and structuring work with R in Roche. A little bit about Roche. Roche is, as Martin has introduced, is one of the largest, if not the largest, biotech company in the world. Headquarters in Basel in Switzerland and offices all over the world, including here in Warsaw. It mostly focuses on oncology, immunology, infectious diseases, ophthalmology, neurodegenerative diseases, among other things. It's also a front runner in diabetes management and personalized healthcare. And it develops medicines and diagnostic instruments mostly, both for in vitro and in tissue diagnostics. You can visit roche.com if you have any further questions or you're particularly interested. I'm going to focus also on the Roche Global IT Solutions Center, which is where I work. It is headquartered here in Warsaw, so it has offices in Poznan and Mississauga in Canada, just outside Toronto, and Kuala Lumpur in Malaysia. The Roche Global IT Solutions Center is a huge department, about 500 people here in Warsaw and between Warsaw and Poznan, that offers IT support for the different parts of the company. So from everything from data science, of course, to mobile application infrastructure, data warehousing, whatever you can think of. Righty. So why rZYPAD? What does it rZYPAD? rZYPAD is a pipeline developed at the Solution Center, and it was originally developed in Poland. And the acronym, I'm told, is kind of a pun acronym. Życiocykl pracorami danologii, life cycle of data science would be the translation. My Polish, even after 5 years in Poland, is still crappy, as you may see. So rZYPAD is a framework for developing and delivering data science projects. We all been in a situation like this, and many POCs, or many of us do not start from a background in software engineering. Many of us are statisticians, researchers, and therefore our code may lack good practices. We end up in a situation similar to what is depicted. We create a bunch of scripts, we work with them, they are fine, they kind of do what is needed. And as long as the end of those products are a report or a paper or just a shiny app, you don't really need to look at the code or what's beneath it. It's not going to be reused again. So that's fine. But in case you want to scale it up for production, a large company, for example, you want to create applications that will look, that is definitely not nearly enough. So the rZYPAD framework aims to solving these problems that we struggle with, or that a researcher struggles with, by adopting some of the standards that are being developed in software engineering. So you want to have, you cannot just have a lot of different scripts, each one with different functions, or the usual error that it works on my machine, but it doesn't work on my colleague's machine or on the server that goes into production, so it's not working on there. Updating packages, now that we have finally our 4.00, which is, wow, a big change. That's going to be a mess, and if you try just to upload it, many packages will stop working, so that's going to be a laborious process. Another common situation, especially in large companies, being there, is this script doesn't, I don't know what this script does. Maybe I should ask this person who doesn't work on the company, has moved to another department, or it's just not there to help you. Or even different conventions and different ways. The classic divide between tidyverse people versus data table people versus base R people, which we also have. So it all starts with the proof of concept and how we want to move development from the proof of concept to productionalization, production, operations, however you want to call it. So proof of concept is one thing. We did develop a certain idea, and then you want to move it to production and operations, and this is how it is usually done. Many times also production and operations is divided into completely two different parts. Development proper, in which the application, the code that was developed in the proof of concept needs to be scaled up, made it available, put it in some instance, and then ship it, put it there, and then maintained with operations through time. And this is how it usually works. And this indicates two different ways in which these two things work. On the side of the proof of concept, we have that the data is usually just a data dump. Access the data from some Excel files or from CSV or from some database. You create a data dump. It's a one-way direction from the data source into your local repository or whatever you have. You process this data, you clean it up, you do some magic, and we do some stuff. Train a model and train the model until you are satisfied with it. Your R squared is sufficiently high, or your RMCA is sufficiently low, or whatever criterion you want to choose. And this is usually done once for a specific piece of data. Your code works, you prepare, you write the paper, you get it accepted, and it goes into publication hopefully 1 year later or even more. And then if you need to review it, okay, you adjust it, but then it's done. That is the proof of concept. But the way things work in operations, in production, what does it mean, data science production? It just means that your code has to run multiple times. In a nutshell, in a single sentence, that's it. Your code needs to run again and again, usually with different data, So different data stream. You have, for example, data from patients, and they change, and you need to update regularly report. That is a data stream. It needs to change. And the output of that is, of course, some model results. The data pre-processing is not particularly important. The data is supposed to be clean, and you don't need to upload the data. Or sometimes you do. An important element here is that in the proof of concept, you only need that the model is successful. It works. That's it. It doesn't matter that it took an hour or 10 hours to build, or that it is inefficient, or that it, out of 10 times, 5 it failed. You need, that's fine for the proof of concept, but for the operational part of the production operation, that is definitely not acceptable. You need code that will run, that is reliable, that it works as it is expected, and usually, although this criterion is not really sacred, that is more or less responsive, that it can have that can be deployed fast, so that you don't necessarily want to wait a full night for the results. Although, as I said, this in some cases that is the only way, especially for large image classifications and stuff like that. An important element of the productionalization is that it has to work all the time. It has to serve all the time, and it will work until decommission, until this particular platform is no longer used, and regular patches will work. In terms of the skill set and the mindset, proof of concept on operation and productionalization require two different skill sets of skills, and two different mindset. In the terms of skill set, data science for the proof of concept, you need data scientists, you need people who are experimenting, you need people who are knowledgeable about the stuff they are doing, about the area they are modeling. And the important thing, you have a mindset that, okay, you just need to minimize the error and have a pretty good model that is accurate enough. You usually want to run with the latest gizmo, with the latest tool. Oh, there's a new version of package tidy models. Let's use it. Oh, there's a latest version of R. Let's use it. You have a lot of space for trying to experiment, to think. You have a lot of decision freedom. If you ever worked in a production environment, you will know that that is definitely not the way things are. You need, you are looked with some bemusement by software developers, Java developers, or software engineers that say, no, all that freedom, all that happiness will not work here. You need to have, your code needs to be stable. It needs to be, you need to deal with security issues. Who will log into your application, and who has access to it, or is the way the data is consumed by your application, is it secure? Do you have any concerns? That is not usually the kind of concerns that regular data scientists, run-of-the-mill data science, or run of the academia data scientist has. Usually not if you come from a researcher background. And of course, you have the all good corporate requirements. Corporate requirements seem like a horrible, boring and stupid thing until you take a larger picture and you see that corporate requirements, they exist for a reason, and that reason is to make things and applications work well with one another. You may want to have your application running with your models in your choice of things, but that will work only for you and your gang of friends, not necessarily work well in a large corporate environment. So you need to have tools that will play well, and that's the reason for corporate environments. So the way it looks, the way it is supposed to work is as depicted above. You develop your practical, your proof of concept. It works in a way, and finally it's done, and then you pass it to the poor guys who are the productionalization and operation, and they work on it, do their magic, and that's it. And you can go back to work on your new proof of concept. That's not the case. In many situations, we have something resembling the second part, that you pass the code to production team. The production team starts working on it, and they don't understand something. There was some code that was not well developed or was not clear, so pass it back to the developers, to the proof of concept team, does some fix, goes back to production. Oh, there's another thing that needs to data, and so on and so forth, a number of times, until finally all errors are fixed, and more or less that works in finally production, and can be maintained. Or more often than not, the whole pipeline is discarded, and someone gets, okay, cut the money, this makes no sense, let's move to something else. The rZYPAD way is something like this. So it's us with a transition, a gradual transition from production to operation. You start with a pure proof of concept mindset, skill set, and whatnot, especially for the first initiation part, in which you will conceive the work, and you decide what is exactly what needs to be done, and you adopt a very exploratory mindset. But you immediately have a room for thinking about production issues, and you immediately move, and you go gradually in that path, incorporating more and more elements of production, so that you have what is commonly known. This is not we're not discovering the world. This is essentially the DevOps mindset. So we divide this kind of approach into three phases. Of course, project initiation, which is a pure exploration of what is exactly what needs to be done, what kind of situation is it, what counts as a success, what actually would be sufficient, at least initially. Of course, this which changes and pivots and moves and whatnot. And the data access, of course, is granted. Sometimes in some situations you may wait a long time, talking about a month, for getting access to the data. In a company I worked before, I kid you not, we waited over a month to get access to the data. So the client will not give us access to the data until a month. So what we ended up doing, simulations. We made our own data. If you cannot have data, you invent. But usually you want to clear this thing as soon as possible. You want to have a template for projects, what will need to be done, and have the right questions to ask. Then you move into POC. Then you do really move to POC, and this is when you do exploration. Is this thing feasible? Does it make sense? Is the minimum viable product actually useful? Is it something that can be worked on, and can we then go and improve and adding features and stuff like that? Or no, this makes no sense and is useless, so kill it. So this is the POC execution, but it's always a POC that is meant to have production and large-scale operations in mind. So you gradually move like that. So by the time you reach there, you transition smoothly into production and operation, and you have this kind of thing. Okay. So just in terms of that, in project initiation, you just work a little bit on this element, and in PO6 you move from more and more parts of that and implement the different components. So don't want to bother with you in this. This is very high level, and of course, and what we're actually doing is that we're implementing rZYPAD in two different kinds of projects. So for Python, projects and for our projects, we are in this stage, because of course this is very self-referential. The pipeline itself is being developed until the pipeline itself. Yeah, we all love Bertrand Russell. So so we are moving into the part in which this application, this platform, this framework, this idea can be moving into operation by developing specific tools. Oopsie, this because it was an animation and I messed with that. So let me just move the window with our faces to some other ways. Okay, so the way this thing works, especially for R, is that you have your project set up, which is done with a bunch of different R packages for using specific templates. You have tools for code development. Of course, you use Git. You adopt Git flow model for this is not continuous integration. This is doing with releases. Some specific tools for pre-commit. We're going to explain later what is that, but essentially that your code gets checked every time you do a commit, so that it checks that your code is compliant with certain rules. You can modify which rules are those. You do some unit testing, of course, of your code, and like the integration testing that it works well with all things. You build models with whatever package is your choice, and we recommend the use of tidy models, and also MLflow, which is an external service that will allow to save all the different models you've been building, so you can then monitor which models was best. It's essentially a little bit like a Git for models, although a little bit more functional than that. And we Docker the whole thing. We put everything in container so that everything works in isolation. And oops, I moved something that doesn't work, and you saw my screen. Ooh, that. Okay. If I go next, why that? Okay, let me. What was that? Okay, I think I have an issue with my connection. Technical problems. Don't we love them? Okay. That was a bit of a flop. So let's start again. No, let's not start again. Let me see. Okay. think this, oh yeah, missed this one. Yeah, this is the goal that we try we'll try to build. And again, I need to move this guy over. And this is a general, very high-level architecture that will tell you probably absolutely nothing, other than what we're trying to do is very complicated. But essentially, we want to integrate a bunch of different tools from code repository and a specific platform and automated tools for checking and for running and for making sure that your code is still efficient after you moved on to other things. Okay. So working with rZYPAD. rZYPAD is a specific implementation of rZYPAD, of this życiocykl, praco, something, something, dano, something, something else, the life cycle. And it's obviously made for our projects. Yeah, in general, for every project, the most important thing, as I say, is standards. This is, I think, is one of the most important things. So what we need for having a successful team, you have to have standard, and this rZYPAD framework, what it aims is to develop standards. What is the key element here for that? Okay, I will go over to this in a second. The most important element for that is that we will develop packages. We'll go into that in a moment. Just in terms of distinctions, gonna make the difference between rZYPAD as a framework, which is the whole thing we're talking about, rZYPAD, which is the environment for working in our project, and rZYPAD is the package, specifically an R package we built for working specifically in this kind of thing. I'm not going to go with this because I've seen that it's late enough, and I'm going to go with this particular slide, which is the key element here. Project as packages. We are not the first one to come with this idea. But we think is a very good idea. So deliver all your projects as packages. Seriously, our packages are the best thing invented. It's sliced bread, and it's a very good way of shipping your project. Even if you never think of going into production, even if you never think of scaling it up, just the change of mindset that this thing that developing in packages is pretty good. Even if you just want to make reports or papers, having your data structured, having your project structured as a package is incredibly good, and I invite you to adopt this way. So of course, I don't think I need to explain what a package is in R. So you will build, you just have a common structure way. Anybody who was working R knows what the structure of a package is. Everybody knows the general common structure. You're tracking all the package dependencies in the description file. You can immediately use DevTools, check and test that for running tests, that it goes into that, and they use this package, which is something we make heavy use of. Is a pretty powerful tool. So it's not like we invented many things, or we have built some packages. Is that how we integrate the different tools that exist, and many of them, into something that we can develop and we can use for development. So project as packages, and your code as vignette, your documentation as vignettes. Is an important mindset, change of mindset from the analyst that the most important thing that they do is the deck of slides or the RMAC on paper, to switch to code, and the reports or whatever it is sit along with the code. That is the important thing. And we build, of course, sites with package done that we usually publish to either our own GitHub instance at Roche, or onto RS Connect, which we also have. In a particular instance, so we develop a container that we develop, in which you develop your packages. So we provide you with Docker images in which you can deploy, in which you can build your package. That is your development environment, in which you have everything you need to collaborate with colleagues, independent of what the system have and everything. We have basically two images and a Roche Artifactory, and in this image we have all the system libraries, the package that need, everything gets combined, and then you just get the Docker Compose and run this thing. We can have a demo in a moment. So this is essentially a schema of how you work. In your host machine, you have the container in which your project file exists, and this is you develop packages inside this image. You just mount as volumes some element that you may need to have, a working directory and keys and configuration files to enable you to connect to the rPid bucket instance, which is the repository mostly used. And we also have open ports for accessing from the browser internally and from connecting with Plumber via an external service. Okie dokie. So how this thing in generally works. In a team, we try to focus on small teams for prototyping, and then we build them up with further people when we need to move into production. So it's like a growing team. We have one person that is responsible for setting the whole project, the whole environment up, and then we have developers who will be actually building the package and doing different things. So we have an image that you need to have in your computer, of course, Docker, Git, and Bitbucket, which is kind of a pretty standard requirement that you need to have in your machine. And we have built this with this site, which we have in RS Connect, that has all the information you need. This is a standard package now. Now, if I may show here the site. Unfortunately, it's only available for Roche employees, so I hope you will not be too pissed, but essentially it contains all the information that we provide all the information that it needs to have, and you just need to copy the Docker Compose file, and that's it. So we have a repository where our image is stored, the volume that they mount. If you want to have your or a particular folder, you can mount it, and then you only need to fire up your container with this command, Docker Compose up, and stop it when you're done. This is the main site, by the way, for rZYPAD. So here we provide all the information that the person needs. The main page, of course, is the how to get the image, and then we have all the external information, how to actually run this kind of environment. Most of the tools are built around they use this package. Here you will be able to create a new package, of course, with the GUI or from the console if you're more kind of a console person, and you can also set. You will also have to set the remote with that. Since we have a pretty strong firewall, we cannot do that automatically from the console, from the session in our studio. We have to go with we have to do it manually for now. Okay. So a bunch of documentation that all the users, when they need to develop a project, this is the landing page. And it's very useful for any developers in your team that you collaborate in, that everybody is, we say literally, they are on the same page. I mean, they come to this site and they have different information with different articles, how do we actually go and build applications, etc., etc. So this is the site in which everybody just type rZYPAD, and they have all the information that they need. Okay, so you develop packages, you have all the different tools for testing. Okay, you go away, you present from this slide. No, not this one. So it takes a while. Okay, so we have this particular one. You get the Docker image and you start developing ready code. You're ready code. If I may, I just downloaded this thing. It's going to upload a demonstration with other. This is of course an RStudio session, which is the session with the rZYPAD already placed. So you will go and connect to this with a local host, and you have the session already ready. So here, if I wanted to start a project, I can just click new directory, package, call it whyr demo, and you can create a project immediately. We also have projects that can take advantage of Drake. And Drake is quite a complicated package for building application, for building pipelines. So basically, you have a make file, or equivalent of a make file. You have a master file. Yes, I know this is expected because of, but I have built a project here. So what Drake enables you to run pipelines that that will cache the results of the different computations or different tasks that you, or different targets as they're called in Drake, in a cache, in a hidden folder. And that saves a lot of computational time, especially for development, because if you need to rerun the whole thing, it will only run the parts that have changed, or for which dependencies have changed. So in that sense, is particularly useful. Okay, so here we are. We have a new project. We have all the different structure. We have the analysis folder, and we have a series of documentation that that give you the environment. So here you can immediately start. Everybody in the different teams will have the same environment to develop the applications that they need. Okay. So yeah, we make heavy use of these functions, and I think we really recommend them to be adopted by almost everybody in the R community. That immediately will automate which functions you will automate a lot of your work. So you need to create a new function. You just use R, and it immediately will create it in the R folder. You can use tests. Everybody likes. So that kind of is a neat result. Yeah, we push everything to the remote, and this is the part that we did not manage to get automated quite yet, and that is essentially it. An important element of that, as I hinted initially, was the pre-commit package. I don't know if you know it, but basically it's a very nice ways of having Git hooks. If you don't know what Git hooks, recommend you look them up. Git hooks are basically small snippets of code that will run every time you do a Git commit. So every time you try to commit changes to your code via Git commit, and before you allow them to push them to the remote repository, it will run a series of checks. Checks like what? Checks like that your code is parsable. I mean, you haven't omitted to close some bracket or some parenthesis somewhere. The code is actually good code to check. It will check that, for example, your code is styled in a particular way, or that your documentation is up to date. We'll do some checks. That avoids the situation in which somebody pushes broken code to external repository, and then somebody else clones it, and the error propagates to everybody's machines. Not good. So having pre-commit is pretty cool. Pre-commit is a package that that wraps around the Python library. So yeah, that's essentially there is to it. You have a pre-commit configuration YAML file that you can configure to add the different checks, and the way it just works, you will just get a notification that some functions were modified. So you wrote a function that was not properly styled, and you will get this error that your code was not properly styled, and it will attempt to produce the changes itself, and it will flag it for the human, for the to actually check. So all in all these tools, what they help us is that we are everybody developing and working in a similar way. We also make heavy use of Google Docs in this company, Google Drive essentially. So many of the situations we still have docs. We still have a lot of information there. So we make use of the Google Drive and Google Sheets for packages for accessing the data, which can also be added to the system. You can add auth tokens or hidden tokens for accessing the drive, and pull and push the modified files as needed. Yep, we had a workshop, but this, I think it's not that much useful for people outside of Roche, so I'll skip immediately to the end, and I will happily take some extra questions. Yeah, we also have, of course, something in a roadmap. I mentioned MLflow. MLflow is a framework for storing your models, and it works in such a way that you can build your model and you can push it to the server, and then it will be stored. So you can, so for example, you train a linear model, or you train, I don't know, a neural network with some parameters, and then you tweak your parameters. It comes, of course, with a different accuracy and different versions. So instead of just saving everything to all possible names, which is a bit clunky, a solution for that is to use the MLflow framework that will store the results of your different models, and then you can just have them with the different specifications. So this model we built was with such and such parameters, and we get these results, etc., etc., and we'll just collect some KPIs based on that information. This is still in the roadmap of things to do, as well as the REST API and the API for the model for R is not up to date. So yeah, we have to work with these people to work to get it working to our standards. And finally, I want to thank my collaborators that were working pretty hard to provide a working instance for this. Maria Trivian, Justyna Zankowiak, and Krzysztof Słomiński, that are working with me in this. And without further ado, if I can think you can stop it here, and if there are any other questions, Martin, you can fire them. Thank you.
Yeah, that was a great talk. Thanks, Lorenzo. It looks like this is a long process, but you really mastered that. The pipeline flow was very amazing. I can tell that I would like to have such a flow on my own, and I'm very jealous. So yeah, there are a couple of questions on a live chat. Most of them related to the flow and the used technologies. Let me just start with the first one. So I can tell in the audience as well that you are using Jira. Have you used any other tools like Trello or anything different for project management? What are the biggest pros, biggest benefits of Jira in comparison to other tools?
My favorite subject. No, but we make heavy use of Jira, and Jira is, how would I put this? Jira is a tank. Jira is the Swiss knife of tools. You can do a lot of things with Jira. The problem with Jira is that it has so many options that can feel overwhelming. So if you have a light project that it's more or less lightweight, or you want to do more or less fast, having that is insane. You have many different configurations. You don't have to use them, all of them, but it's extremely good. For large scale collaboration, you need to collaborate with a large team, which is what Jira is for. I mean, I'm talking about 300 people, or even just 10. Jira is extremely good. We also have of course we have GitHub Enterprise actually, and we use projects for that, and that is standard. You know how it is. You have project, you have boards, and that's pretty cool. But sometimes, for example, I miss the swim lanes and I miss some of the tools that you have in Jira. We also have Trello, but Trello we use it mostly for non-code applications. Because one good feature of Jira is that Jira can track specific branches, which is something that GitHub cannot do. So you can create an issue tagged to one or more branches that will follow that, and that is extremely useful. And with Trello is a completely different instance. We also have GitLab. Which I'm a recent convert to. I used to be a GitHub guy, but now I'm a GitLab, and I love it. But we mostly have it now for sandboxing, and not so much for production level. Yeah. Sorry if they were long-winded.
No. That's pretty interesting how big companies are making their decision and choices regarding the use software. Good that you mentioned that you're using GitHub, and I saw that Bamboo is also used, and that's another question. If that's a continuous integration tool, have you considered GitHub Actions? Like you can have the continuous integration and the repository management at the same place.
Yes, we have, and we have all the Atlassian tools, right? So we have Bitbucket, Jira, Bamboo, and Confluence in a single type space. Actually, we have at least 2 different versions of. We have the server and the cloud. So we have a lot of things. Huge company, different tools. But and GitHub, we also have that. You still in GitHub, we also configure that. Sometimes we do it with Travis for GitHub, or Jenkins, which is also very popular. And for GitLab, we use the GitLab. GitLab, we have it as of this month. So we also have it. Also has its CI/CD tools. So we're happy to use those.
You're pushing that to its limits. I see many people using multiple various tools. Are there any plans to make it clear that all future projects should be held on this platform with that setup, so that people can immediately jump on the project and realize, okay, that's the software setup that I'm used to? Are such plans?
Yeah, but we're trying to fight the 15th standard. As you know, the joke, there are 14 standards. That's insane. We have to have one standard that covers everything. Now there are 15 standards. because that's how it works, right? That's after XKCD joke. But the thing is that but the company is so big and so many departments that getting everybody on board is kind of difficult. For large scale organizations, it doesn't make sense to try to have, I don't think to have one standard or one way of working that will cover, because you will never coordinate. So it's better to have solutions that can play well with all the things. And so for example, we develop everything and we put it into a Docker container and we ship it. And then I don't care if you're using Kubernetes or using Slurm for orchestration or whatever you're using. You know when. So there are some standards that are industry driven, but of course, different ways of working. It's inevitable.
Makes sense. There's one question from Sean regarding RS Connect. Are you using that for as a package manager, or you rather handle dependencies with Docker? And there's question from Sean, if you could elaborate on the setup. How do you use RS Connect, and do you have a Server Pro?
Yeah, that's a very good question. We are of two minds when it comes to RS Connect, because RS Connect we mostly use for prototyping and for publishing. RS Connect is the platform we mostly use for quickly deploying a Shiny app or Markdown or tools like that. But for large scale production, and then it goes the whole thing. We just from wherever you are, RStudio server or your local RStudio instance or a Docker container, whatever it is, you just publish there and that's it. And that would say is 90% of the use cases of RS Connect. Which, as long as you need a platform to publish your artifacts, that's fine. Sometimes you also publish an API that will do the job, and that's it. An alternative is, of course, when your code needs to run embedded in a larger application. For example, we have applications that do a lot of different things and use multiple languages, and there's a module that will work in R. Okay, that is usually managed with containers and goes with a completely different orchestration system. The thing we're trying to do as well now is to integrate both approaches. So, for example, we can have RS Connect integrated in Kubernetes, so we can actually publish containers and directly have it managed. But they kind of overlap in many different ways, and we try to figure it out exactly how that will look like. RS Connect usually ships with its own launcher and with its own orchestration of containers. So it's a little bit tricky.
I see.
I don't know if I answered your question or Sean's question.
Sean, if you have any more questions, please pass them on the live chat. And I just have a new one. So this is really interesting flow for the script analysis. Is it also possible to prepare a containerized Shiny app that will be used by any internal team with the rZYPAD ecosystem that we prepared?
Actually, we cheated, because for Shiny apps, we found out Golem. And Golem, the Golem package, Colin Fay, I think, is the developer of that one. Already develops in a very similar way. So it develops Shiny apps as packages. So that's it. You don't need to do anything. That's already covering your issue. And that, of course, you can put in a container. You can put into a container. Just make sure that your app can communicate via Plumber REST APIs with the external world, whatever all the configuration you have, and that's it. So for we did not cover the case of Shiny apps, because we already have a solution that does 99% of the things we want.
I was just wondering if that can be also.
No need to reinvent the wheel.
Yeah, for sure. You can use your time to invest in rZYPAD. One part was unclear for me. So for projects, you had code as vignettes, but when the project was set, there was a directory called analysis.
Sorry, that was an old version. For a correction, we don't develop code as vignettes. Vignettes are a side effect. Your code is your functions. Your code is your function. Whatever it is a function. And you have to think that if your code needs to run in production, you're making functions, and the functions will be called to execute whatever it is. So say you have a forecasting service, right? So new data comes in, and a model is trained. That model, you have all the pre-processing functions that will clean the data, and the modeling function that will do that. And then on side of that, you can call those functions from a vignette. And that will basically populate your report and generate your whatever it needs to be done. But your code are your functions, and that's this in R. The analysis was an initial version. That's what version 0.2 is different than version 0.3. And we're thinking of having the analysis separated. So you can have interim data and stuff like that. We decided that that was too much of a hassle, and it was creating a lot of problems with the checks. So okay, use vignettes. The way we did this in general is a lot of laziness. We adopt the standard of lazy evaluation for how we work. If it's done already by someone else and it works, use it. We give credit where it is due, but it's good. There's a lot of good development out there, and we'll be stupid not take advantage of it.
True. So just to be clear, so there are tests in tests, functions in R directory, and code that is executed. The functions that are called are in vignettes, and that's what is actually evaluated on a production.
So the code that is evaluated in production is the code in R, in the R folder, essentially, right? That is the code that is called and used. You generally don't want to put code in your vignettes, new fresh code. If you need to create a function for whatever it is, you don't put it. You should not put it in the vignette.
But the script actually call all those functions, and like line by line, there needs to be a script that lives. And does it live in vignettes or does it live in R? The stuff that calls the functions.
In R.
So
so when you have your service in production, essentially you have a package, right? And the production environment, what basically it does is load the package. You have an R instance that will load the package, same as any other package. And this package calls functions. So my project main function, say, that is what is called by the service. The vignettes are like any other package vignette. So it works exactly the same way as any package.
Yeah.
In production, you will have package installed, and then you make the package do the job that needs to be done. You have a scheduler, you have the whole environment. We are covering that part, but there's a lot of work we haven't done quite yet, so I didn't want to show.
Yeah, was just wondering where the actual script that uses the package is stored, and
yes, that is the production environment. Yes, so you have to have two different. That is the complication. You have to have from the development environment, you will ship that into the production part. So you will have the execution environment for that. But it's developed continually. It's developing continually. So the package is constantly installed until you reach the point that you achieve the goals that need to be done.
Okay. One more from Anya. Does this flow mean that you have a separate Docker image for every project that you develop?
The image is the same. The core image is the same. Is the rZYPAD image, the main image is the same. The instance, of course, the containers are different, but the image is the same. So, for example, if you are working on a prediction model, and I'm working on a classification task, we are working on the same image.
But various.
Just that you're working in a package that will do forecast, and you will have the dependencies that your package will need. And I'm working on something else that needs classification. So I'm getting the image, need that. yes. But the image is the same. And of course, within the container, then it's up to you to decide if you want to create versions of the container. But usually, if you have to create, for example, multiple packages, sometimes you need to create packages. You prefer to have, and it's generally a better approach to have multiple packages instead of one package that does everything. You can have multiple packages in the same container, right? So they sit along with one another, same as you would do with that, and they can share dependencies or not, or have them isolated as you need. It all depends on how much is isolation.
So there's one image used across all the projects, and you have the frozen version of R and predefined versions of R packages, and they are just reused all over the place. And how does that work if you need to extend the list of R packages or to update one of them?
So we need to we connect that with part of the development that you can connect that to a snapshot of GRAN. We have actually a GRAN or Genentech repository, and that is the source of the different packages that you need, and this is what you connect. You will connect and get it. Actually, that's where the source of packages will come from.
Okay, so there are different images for various dates, and you just say that, okay, let's use image from that date.
In general, we are storing the different images. I mean, but we are developing this thing kind of sequentially. We don't not branching. So we have image 0.3 and image 0.2 and 0.21 and whatever. So they are sequentially. You can always roll back and use a previous image. If the previous image was working for you, you need necessarily to update to the newer one. But we recommend always the latest version. Sure. And the image itself is, of course, customizable. You can create your own Docker file if you really need to just change the from statement from this repository, clone this image, and add extra layers for system libraries that you need to expand with. We don't support that, but we cannot really prevent you from doing that. But we don't support that in that we are not testing and checking that. That's on you. You're on your own. You deviated from the standards and you pay the price. But it's certainly possible for prototyping.
Okay, we've got a reply from Sean that your answer covered his question, and there's a new one on how does the model monitoring process look like? If you could elaborate, just a few sentences.
Yeah. So MLflow is a service that you log in and you have you set this up and you have a package, an R package that enables you to communicate with this via essentially a REST API. So you build your model, and when your model is trained, you just add a line that uploads this model essentially. And that model is then stored, and you continue building a new model or something like that. So every time this model has a unique ID, and it goes to train with that. That's it.
Okay.
Flow, or read it, download a snapshot locally to basically a table with the results, and you have all the different models that you've been built, that you have actually been uploaded, not necessarily built, with the different parameters. So it stores all the results and the configuration of the model that you had. Yep. We use this only because it's aligning with the Python development. We have also specific similar solutions in R. Model down was a similar approach, although it doesn't save. It more or less saves the result of your model with a series of things, but not necessarily store every model that you've built.
Right. I think those were just all of the questions. In my opinion, this was very advanced talk, and I'm very happy to hear how you develop it in-house. There's a lot of stuff that we can learn from, and probably now that's a good start to actually get deeper into the details. I'm very jealous you have this all sorted out and a full team working on that on a
Right
daily
now.
basis.
Yeah.
And heading to the end, Lorenzo, thank you again once more for your talk. This was a pleasure. I hope there will be many questions after the talk. You can always write an email to Lorenzo or find him on LinkedIn and send a message. I think that's fine. And yeah, see you guys next week. We will have a presentation by the authors of the data science with our book. John and Nina will be presenting the next week, and happy to have them. And we will have some discount codes for the book. And yeah, that's all for today. Thanks, Lorenzo. And if you have any last sentence, any last famous words to say, then take your chance.
It's been a pleasure. Thank you very much. It's been fun doing this. So I hope you had at least as much fun as I had.
Okay. So thank you all, and see you next week.